All right, in this video, we're going to quickly review solving quadratics. So the difference between graphing and solving is that they don't have a y in them. They only have an x or an x squared. And so we are solving for the x value that will make the statement true. All right. In limited cases, we can use a square root to solve these problems. And that limited case is when we only have the single term of x's in it. So these are the ones that do not have that x term. Okay. So of our ax squared plus bx plus c, which we should be very comfortable with by now, we don't have the bx term. If it doesn't have the bx term, then we can just simply get the x on one side and everything else on the other, just like we've done most of the year in algebra. And so that would involve us on this problem simply adding 18 to both sides, giving me 2x squared equals 18. Now I got to get x by itself by dividing by 2. I get x squared equals 9. And then I need to introduce a square root to get this x by itself. Just like I added, just like I divided, these are all operations I took to isolate the x by itself. The final step is I need to make the squared part go away. And the way I do that is by taking a square root. When you take a square root, when you introduce this symbol, then you have to remember that that gives you positive and negative the answer. There are two values that will make x squared equal 9 true, a positive 3 and a negative 3. Many of you forgot the positive and the negative. All right, so pause the video and try these next two on your own. All right, the second one, I'm going to add 3 to get the x squared by itself, leaving me with x squared equals 4. And then once again, I'll bring the square root to the party. And when I do that, x squared turns into x, and 4 turns into positive and negative 2. All right, next one, I'm going to add 27 to both sides. I won't usually show the math here because I think we can all successfully add a 27 to both sides without showing it. But if you need to, go ahead. The same is true with dividing by 4. I don't really need to show that because we can all just kind of stick a 4 under a 27 without much difficulty. All right, this one, we're going to follow the same game plan, but the result is going to look just a little bit different. Because while I can take the square root of 27 fourths, it's not going to come out to be a perfect whole number or integer. But that doesn't mean we can't do it. So I get x equals positive or negative the square root of 27 fourths. Now, at some level, like we could count this as correct. But it is very, very barely correct because we did not simplify this at all. When we are taking the square root of a fraction that you can't simplify on its own, then what we can do, per the rules that we learned, is we can actually answer this by doing the top and the bottom separately. Okay? The bottom is nice. It can turn into 2. Square root of 4 is 2. The top, let's just kind of go pull off to the side here and simplify and then bring the answer back in. So 27 is simply going to be a 9 and a 3. So 27 is 9 times 3. And I know that the square root of 9 is 3. So this is a 3. The square root of 3 cannot be simplified. So the square root of 27 is 3 root 3. And the bottom we can do. And so we have an answer of positive or negative 3 square root of 3 divided by 2. And that's that. If we wanted a calculator answer, we could certainly do that and round our answer. So in my calculator, I would simply find the square root of 3, which is approximately 1.732. So if I wanted to go further with this one, which I don't care if you do, you could write x equals positive or negative, and then I would just have to do the math on 3 times 1.732 divided by 2. So if I do that, I'm going to multiply it by 3 on my calculator and then divide the answer by 2. And so this is approximately equal to 2.598. And you could round that not too dramatically. Some kids are rounding that all the way to 3. 3 decimal places is a good rule of thumb when rounding. All right, so those are the easy ones because I don't have to take any extraordinary method to get the answer. Next up will be methods that cannot be solved using square roots.